Basics of battery operation. Batteries are vital in our society, an upper level in the scale of ability for humankind. They give us the power to store and manipulate energy. They are everywhere from our watches, cars, computers, pacemakers to the space shuttles and the space station. The more complex is a society, the more omnipresent and the more dependent we are. A big downside is that most batteries have a limited lifespan, and although replacing some is relatively inexpensive, replacing others can be a big blow to our personal economics. Thus, anything we can do to reduce that blow is something that deserves our attention. That is the reason for this article. The subject is such that I divided it in several parts. The first part is dedicated to the lead-acid battery restoration. They are the most broadly used rechargeable batteries today, and replacing them has become quite expensive due to the constantly rising cost of the lead and lately the sulfuric acid. We find these types of batteries in our cars, electric cars, golf cars, trucks, motorcycles, airplanes, boats, forklifts, solar systems, etc. Now, to bring an easier understanding about how to restore a battery, we are going to start by explaining simply and briefly about what a battery is, how it works and why it fails. Let's start by defining what a battery is. In general, a battery is a device in which chemical energy is transformed into electrical energy, and that energy can be used in a controlled manner. For practical reasons, batteries are classified in two types: a primary battery, when the battery can only be used once, disposable, because the chemical reaction that happens inside is not reversible by simple means, and the secondary battery, when the chemical reaction can be reversed by applying electrical energy to the battery, rechargeable. This reverse reaction capability is what enables the batteries to be reused as storage devices. How does a battery work and why batteries fail? The simplest batteries, better called cells, are composed of two lead plates, one charged positive, lead oxide, and one charged negative, lead, with a chemical solution between them, generally a watery solution of sulfuric acid. The most complex ones have a larger number of cells, but the basic principle is the same. Batteries produce a direct current, DC. It always flows in the same direction. When you use a battery, discharge, the chemical reaction is releasing electric energy through the negative terminal. The reaction of the lead and lead oxide with the sulfuric acid produces lead sulfate, water, and releases electric energy, electrons. If you discharge the battery too much, you will have mostly water and lead sulfate that in such conditions tends to crystallize. When you charge a battery, you put electrons, electric energy, into the battery through the negative terminal. That energy activates the lead sulfate, breaking it into lead and lead oxide and sulfuric acid. That causes a chemical reaction which stores electricity. The electric current is produced by the presence of a surplus of electrons from the negative plate that flow toward the positive plate that has a deficiency of electrons via the sulfuric acid. In summary, the chemical reaction which stores electricity in the battery involves transformation of lead sulfate in an aqueous environment into the lead on the negative plate, and the lead oxide on the positive plate, and an aqueous solution of sulfuric acid. Conversely, when the battery is used, discharged, the interaction of the lead and lead oxide with the sulfuric acid produces lead sulfate, water, and electric energy, electrons. These reactions work in both directions. There is one tragic flaw. Lead can combine with sulfate in two different ways. The first, discussed above, is beneficial. The second way forms a crystal which does have very little or no capability to efficiently conduct electricity and cannot easily be converted back to lead or lead oxide. Every discharge leaves a fine layer of crystals on the plates which little by little reduce the available plate surface, battery's reaction area, and consequently the battery's potential to store and release electricity. As a wider and thicker area is covered with this lead sulfate crystal, the battery loses power until it is not longer worth using. What can be done about it? How to restore a battery? Before covering what things can be done to restore a battery, I find necessary to clarify a bit further about two divisions on the types of lead-acid batteries. The deep batteries and starting batteries, each has their own peculiarities and applications. Starting batteries are the ones used in automobiles. These batteries have generally many thin plates. They make a battery capable of providing as much current as it is possible in a relatively small unit. This kind of batteries is designed to be drained small amounts before they are charged again. Deep cycle lead-acid batteries have thicker plates to aid durability. They resist more deep discharge cycles than the starting ones. Deep batteries are used in golf carts, electric cars, are recommended for solar systems, etc. A deep cycle battery is designed to provide a moderate amount of current for a long period of time. If they were athletes, the starter battery would be a sprinter and the deep battery a marathon runner. Car batteries are not designed to deep discharge. When you do deep discharging, active material on the plates is dropped. If you have thin plates, very soon you will have holes in the plates and permanent reduction of the plate surface, consequently reduced current output in storage.